Alright, so this week we're looking at Pythagoras, or Pythagoras' theorem. Basically, this is a formula that you can use for right-angled triangles. So I'll say that again. You can only use Pythagoras for right-angled triangles. The first thing you need to be able to do is to label the triangle. So let's have a look here. Label the sides of the following triangles, A, B and C, where C is the hypotenuse. Now the word hypotenuse is the longest side of a right-angled triangle. Sometimes it's obvious, like you can see this one is the longest side, so we call that C. A good rule of thumb is it's always going to be opposite the right angle. So here, if there's our right angle, opposite the right angle, that must be C. And for this one, if there's our right angle, opposite must be C. So C has to be the longest side. And the other two sides, it actually doesn't matter which one you call A and which one you call B, because the formula will work for it. So C must be there, there and there. Alright, labelling. So let's use it now. So find the length of the hypotenuse correct to 2 decimal places. So a good way to start a question is to label it A, B and C. A and B don't matter as long as C is here. And whenever you solve this, you write down the formula. The formula is A squared plus B squared equals C squared. Once you've got the formula, you substitute these values in and then solve for C. So let's do that. A is 7, so that is 7 squared. B is 9, so that's 9 squared equals C squared. We type that into our calculator. So you can see I've just typed in exactly the same as it is, and you get 130. Now C squared is 130, that means that the square root of 130 must be equal to C. So you could write it this way round, the square root of 130 equals C, and then I'm going to write C equals. So this is called the exact answer because we haven't rounded it, and if you want it to 2 decimal places, that would be 11.40, so 11.40 centimetres. So we do formula, substitute, and then obviously we do the rearranging here. That is the length of the hypotenuse. It looks like it's correct. Remember, it must be the longest side. Right, question 3. Find the length of the marked side correct to 2 decimal places. So let's do this in the same way. That's the longest. That can be our A and that can be our B. So we write our formula, same as the last question. Now this time we want to work out what A is, they've used the letter X, so let's change that to X. Now what I'm going to do here to make it easier for myself, instead of A, I'm going to write X. Now, C squared stays there, and because it was plus B squared on this side, I'm going to take away B squared on this side. You can actually go straight to the formula that looks like that, because A squared would be C squared minus B squared, so you are actually allowed to go to that one, because it's the same formula as this one. I've just moved the B to the other side. Anyway, let's substitute. So our X or A squared equals C squared, so that's 15 squared minus B squared, and our B is 6. Let's type that into the calculator. 15 squared minus 6 squared, and you can see it's exactly the same. So our X squared must be 189. The opposite of squared, that means X must be the square root of 189, which is our exact answer. And to square root 189, we get our answer of 13.75 centimetres. So just to recap, there are 3 types of question with Pythagoras. You must be able to label it. Question 2 is you find the longest side, A squared plus B squared equals C squared. Question 3, you find one of the shorter sides, and you say you just got to rearrange the formula and move the B squared to the other side and substitute as normal. Obviously watch this a few times, give it a go, and that's what we should be doing for week 3.